Welcome to Sigma Solver, guys. Okay, before I start the video, I want you guys to smash the like button. This helps the YouTube algorithm and keeps me motivated. And if you are new here, then subscribe to my channel and press the bell icon so that you never miss an update. Okay, so without any further ado, let's get started. So today we are going to discuss a topic that is Cournot Duopoly, which is an important concept in game theory, as you might know. Cournot Duopoly is basically a concept related to game theory as well as to microeconomics, which determines how the price and supply, that is demand and supply, are to be regulated in the market by a particular firm who is selling any services or products. So basically, when a company, say C1, has a demand, say P1, and another company, say C2, has a demand, say P2. So how the supply, that is S1 and S2, both operate in the market, and how these prices determine which company will make more sales is a typical topic that is more concerned by all the businesses these days, right? So to ensure that we use an optimal strategy while deciding the price at which we are going to sell our product, we need to consider Cournot Duopoly and its various techniques that we will discuss in this video in order to get the best results out of our business. So in this problem, we are given a Cournot Duopoly which operates in a market with the following inverse demand function. That is, P of Q equals 90 minus Q if Q is less than equal to 90. If Q is greater than 90, then it is 0. Okay, so this is the inverse demand function, that is the demand with respect to the quantity, that is the total output, is being displayed here. Like suppose if the total output in the market is Q1 plus Q2, so if that quantity, that is Q1 plus Q2, is less than 90, then the demand will be 90 minus Q, otherwise the demand will be 0. So this is the inverse demand function, and we are given that the total output produced by both the firms is Q1 plus Q2, right? So next thing is the cost of firm 2 is C2, Q2 is equal to 9 of Q2. So let me erase this thing so that we have clear understanding of what we are discussing. Okay, so here we are given that the cost of C2 is 9 Q2. Suppose this is a constant with respect to firm 2. As we all know that while running a business, we need to incur some initial cost in order to set up our product. So that initial cost is the cost of basically setting up the product or making the product. So that is called cost of firm 2. Okay, so this is the cost for firm 2. So again we will read the cost of firm 2 is C2 Q2 is equal to 9 Q2, which is with probability 1 by 3, and C2 Q2 equal to 27 Q2 with probability 2 by 3. So we are given two statements here, that for 1 by 3 times the cost of production by company C2 is 9 Q2, while 2/3 of the times it's 27 Q2. Okay, so this we reached here. Okay, then the cost of firm 1 is C1 Q1, but here we see that there is no probability associated. This means that all the time when production occurs at firm 1, it occurs at a cost of 18 Q1, right? So then firm 2 knows its own cost, okay, but firm 1 knows only the types of costs of firm 2 and its probabilities. As we discussed here, that firm 2 only knows this particular probability, that what firm 2 can opt for, but firm 2 on its side knows with 100% probability that what it will do, right? Both the parties are not communicating with each other in this market scene. Firm 2 knows its own cost, but firm 1 only knows the types of cost of firm 2 and its probabilities. The above description is common knowledge. So this is known to all, but what firm 2 will actually choose is only known to firm 2. Okay, So what we are given here is represent the above situation as a Bayesian game, that is describe the set, the set is repeated twice, of players, their types, their set of strategies, their beliefs and their utilities. So since player 1 is not particular about which strategy player 2 will choose, that is fun 2 will choose, so we have incomplete information in this regard. So when we have in a game incomplete information, that is I, so then we say that we need to go for Bayesian game. If it had been a complete information game, then we could use extensive form games. When there is sequential games involved, we can use the other strategic form games, right, or mixed strategy, Nash equilibrium, all these we can use those when we have complete information about a particular event, right? So let's begin our first question. So there are given two players, that is, let us say there are n1 and n2. Their types are t1. So t1 is for the firm 1, right? Their type is firm 1. Type means the behavior. When we associate behavior into the game, we need to define a particular entity associated to it so that we can assign a numerical value. So for case of firm 1, its type, that is its behavior, is t1. We denote it with r. And for firm 2, its type will be cl or ch. cl is when the situation of when firm 2 knows that its marginal cost is 9. Marginal cost is same as cost, as we discussed above. Okay, so this is when firm 2 knows its marginal cost is 9. ch represents the situation when firm 2 knows that its marginal cost is 27. Okay, so I think this is pretty clear. Let's move on to the next part. So we discussed the set of players and their types, right? Since firm 2 has two types which firm 1 is going to predict and take its decision, so we will say that it will have two types. Okay, so then there are set of strategies. So in set of strategies for player 1, we have 0 to infinity. So why this is 0 to infinity? Basically, when we set a price for a product, we can basically apply any price to it, right? We can set the price as $10, we can set the price as $20, $30 or whatever. Means the largest price we can set is not fixed, so I took it as infinity. So this is the case of player 1. Now for player 2, we will have 0 to infinity into 0 to infinity. Why this into? Because we need to multiply the cases where the events are independent of each other. So suppose in case of player 2 knows that its marginal cost is 9, it can set the value from 0 to infinity. But again, when it knows that its value is 27, it can again set the value from 0 to infinity. So this will be the strategy for player 2, right? So, and here we can say that we can further denote this as SL, right? And this as, let me erase this, this as SH. Means the selling price at a lower marginal cost and a higher marginal cost is known for that. Okay, after this we can do is strategy for firm 2 when it's known as marginal cost is 27 and when it is 9. Fine. So we have come down to like strategies of the players. So this is complete. Then their beliefs. So beliefs is what we call as probabilities in mathematical or statistical terms. Beliefs is associated when we have, as I said, that we have incomplete information. So when we have incomplete information, like suppose I am player 1, so I don't know what player 2 will actually play, but I know its probabilities. So those are my beliefs regarding player 2 about its strategies. So this is what beliefs stand for. So let's calculate them. So this is a Bayesian game. Firm 1 does not know the type of firm 2 as we discussed. Hence we associate probabilities on types of beliefs, right, which is called beliefs as well. So I hope this notation is known to you. So this notation stands for conditional probability. So if we are given A, B, this means P of A intersection B right. So what does this mean? This means that the probability when events A and B occur both, right, both have occurred, and this is what the probability that event B is occurring. So we need to divide these two entities and then we will find this entity. So what is this entity? Probability of event A when event B has already occurred. I want you guys to understand this clearly, because once you understand this, the rest of the beliefs or the how you determine the beliefs is quite easy here. So you need to understand the beliefs associated to this, right? So in that case, let's consider the first part, that is probability of player 1. Since player 1 is trying to estimate what player 2 will play, so player 1 will play its own strategy, that is its own type, which is R, which we discussed above here, right? So it will play this, and in the case of this, that is R, it's playing R. What is the probability that player 2 will play CL, which is its type? So that is 1 by 3, right? Because player 1 is always playing R, so it does not impact the basically probability of player 2 playing any other strategies, right? So it will be P of CL intersection R, P of R. This is always 1, right? Because player 1 has only one strategy of its own. So then we can say that this will be 1 by 3. Similarly, for the higher price, that is 27 cost price, it will be 2 by 3. So once that is done, then we come to the player 2 beliefs. We need to associate beliefs to both of them, since this is a Bayesian game. So what is the probability that player 1 will play type R when player 2 is playing type CL? It will be 1, because player 1 has only one type. Similarly, for R, when player 2 plays CH, it will again be 1. Then we come down to the utilities of the players, that is the payoffs. Each game is played because players are in the intention of attaining some payoffs or utility or gain, you can say, from the game. So the utility of players are as follows. So if we see here, utility of player 1, these are the basically quantities that are associated to the various firms, right? This is for firm 1, firm 2 when it is playing the cost CL, and firm 2 when it is playing the cost CH, and we are given that type of player 1 is R. So this notation is important, since the type is associated at the end, that is type is fixed, and then we calculate what will be the demand and respective payoff. So with 2 by 3rd of the probability, since 2 by 3rd is when player 2 is playing the 27 cost. So according to that, we will have 2 by 3, 72 minus C1 minus CH into Q1. If we see from where it came, let's go back. So in the question we had 90 minus Q, right? And in this 90 minus Q, if we put 18, that is Q1, 18 minus QH, right? So 18 minus QH will be 72 minus Q1 minus QH times Q1, because the demand for firm 1 is Q1. Similarly, 72 minus Q1 minus QL with multiplied Q1. So here again we will have 18 plus Q1 plus Q2 90 minus, right? So this is how we are calculating the demand for the basically what inverse demand function we have. Similarly, we will do with the player 1 when the firm 2 is playing with cost CL. So in this case, it will be 90 minus 9 plus Q1 plus 9 plus QL, right? This will be the case into, there will be no multiplication here, by the way. Okay, so this will be the case, and then it will be 81 minus Q1 minus QL, and here we will multiply with QL because we are using CL in this case, right? The type of player 2 is CL, so we will multiply QL. Similarly with CH, we will multiply QH. So this is how we calculate the utilities or payoffs for the both the companies. Now we come to the second part of the question, which is to find the Bayesian Nash equilibrium of this game and the benefits associated to each of the parties, that is companies that are involved in this game. So the best response for player 2 is the solution of the following maximization problem. Since the utility which we found out was this right here, so the best response of type CL in the case of, okay, so I misunderstood this. The best response when player 2 is playing CL, that is cost is 9. So in that case, this will be the utility associated to that. So in that case, we will maximize this with respect to QL. Why QL? Because the quantity with respect to company 2 is being treated here. So in that case, we will just partially differentiate it with respect to QL and then equate it to 0. So once we do that, we will get this equation. So I'll read it out. QL plus Q1 minus 81 by 2 equals 0. So from here we get QL as 81 minus Q1 by 2 and name it as equation 1. Similarly, we will find the best response of type CH for firm 2 is the solution of the following maximization problem. Again, as you might have guessed, it will be this maximization equation. Why? Because this is the utility associated when player 2 is playing CH, that is its type is the 27Q2 cost. So in that case, we will have this maximization equation, and with respect to QH, we will now differentiate, that is partial differentiation. So we come out to as equation 2. Similarly, we will find the best response for firm 1. Now since there is only one type for firm 1, there will be only one solution to maximization problem, which will be this one, right? This is the equation which I had written first, this equation. So this we will maximize with respect to, you guessed it right, it is Q1. So with respect to Q1, we will differentiate it, partial differentiation again, and we will get this equation. I'm not going into differentiation because it's not in the basically boundary of this video. So we'll move ahead. So the Bayesian Nash equilibrium is the solution to these equations 1, 2 and 3. So as you can see that we have three variables, Q1, QL, QH, and we have three equation 1, 2 and 3. We can easily find these out with respect to like simultaneous linear equation or any other method that you might be using. So in that case, we are able to find these three values, and here star denotes that it is the value of these demand values at Nash equilibriums, or better Bayesian Nash equilibrium. And when we are trying to find out the benefits associated to each firm, in this case it will be just the square of whatever the demand we have supplied, right? So the benefit generally stands as the square of what Bayesian variable is contributing by a firm. So in this case, Q1 was the variable which contributed to the Nash equilibrium, so its square has to be considered. So I hope I was able to convey the concept and understand and make you understand clearly. If you still have any doubts, then feel free to reach out in the comment section below. And if you liked this video, then give it a thumbs up and subscribe to my channel for the upcoming videos. Till then, happy solving.